Today we are going to do a quick review of the 3 different types of quadratic applications that we've looked at this week in class. The first type were the area problems. The length of a rectangle is 4 meters less than twice its width. So I'm going to start by doing my annotations, which is just really underlining important information. Okay? Now I can write some let statements here. The length, so we're going to let the length equal 4 meters less than is a turnaround word, so 4 or negative 4 at the end, less than twice its width. Okay, now if you recall, we're going to let the width just equal x, because that is the side of the rectangle that we know nothing about. And if I were to draw a rectangle for you, actually let me use a darker color, the rectangle is going to look like this, where my length is 2x minus 4 and my width is x. Okay. The area of this is let's do green. The area of that is 70. Okay, what I'm going to do is set up my equation. I know that the area formula looks like area equals length times width. So I'm going to do the area, which I know is 70, is going to equal my length is 2x minus 4, and my width is just x. And then I need to go ahead and solve this. So first thing I'm going to do is distribute this x into the binomial that I've got in front of it. 2x times x is 2x squared. X times negative 4 is negative 4x. And then I have this 70 still. Before I can solve this quadratic function, I need to make sure that I bring the 70 over to the other side. And there's nothing for it to combine with, so I will just put it right there on the end. And now it will equal 70 minus 70 is 0. It should be a 0. All right, now I am ready to factor. So the first thing I want to do is see if I can take out a GCF. 2 times 1, 2 times 2, 2 times 35. So I do see a GCF right there. I'm going to take out that 2, and then I'm going to put the leftovers in parentheses. 1x squared minus 2x minus 35. And then I take the leftovers here, and I'm going to do the x puzzle with them. Negative 35 goes on top. Negative 2 goes on bottom. I'm thinking that 7 times 5 is 35. Whoops. 7 times 5. And I need them to combine to give me negative 2. So let's do 5 minus 7 will get me to negative 2. So my factors that I get from that are x minus 7, x plus 5. And then I bring down this 2. I'm almost finished. What I need to do last is to use my zero product property. So I'm going to bring this over here and just write this down. X minus 7, x plus 5. The zero product property, if you remember, it said that if I take each of these and set them equal to 0, because I am failing to write down here that this still equals 0. Okay. So it equals 0, which means that one or all of these three factors must be equal to 0. Okay, and then my last one, x plus 5 equals 0. And then if you solve them, let's see, 2 equals 0, that's not a true statement, so we just discard that and act like it's not there really. If I add 7 to both sides here, I get x equals 7. And if I subtract this 5, I get x equals negative 5. Hopefully you remember in class our discussion about talking about length and width. We cannot have a negative solution because you can't have a negative length or a negative width of anything. So we just throw that answer out, and obviously we already threw that answer out. The only thing left is this positive 7. So now what we're going to do is we're going to bring that 7 up here, and we're going to figure out what is the actual length and width. Well, the width is right there, x equals 7, so that one's done. And then this other one would be 2 times 7 minus 4. So 14 minus 4 is 10. So my width is 7, and my length is 10. And if you double check that, 7 times 10 gets you back to your area that was 70. And that's it. Let's go look at example 2. Example 2 is still a quadratic application, but this deals with consecutive integers. If you remember, consecutive integers just mean that they are in order. So if I have just plain old consecutive, that would be like 4, 5, 6, okay? If I were to write them using variables because I didn't know their values, then the 4, the first number is x, and then you think about how do you get from 4 to 5? You add 1, so then my next number would be x plus 1. And then how would you figure out the third number? Well, how do you get from 4 to 6? You add 2. So then the last number would be x plus 2. Okay. What about consecutive even? Okay. Consecutive even. An example of that would be 10 and 12. Well, the first number, if I don't know it, is always x. And then your second number. You want to think about how do you get from 10 to 12. You add 2. So my second number would be represented with x plus 2. And a lot of students think that the consecutive odds are different, but they're really not. If I have 11 and 13, the first number is x. How do you get from 11 to 13? You, again, are just going to add 2, so I'm still going to have x plus 2. So whether your problem calls for consecutive evens or consecutive odds or just plain old consecutive, this is what you're going to refer to. Okay, so let's look at our problem now. We're going to find 2 consecutive positive even integers. So I want to use this one right here. Okay, so I'm going to let x equal, let x equal the first number, and let x plus 2 equal the second number. Okay, now I do need to pay attention when I get to my final answer that they want me to find the positive solution. Okay, all right, now let's get into further translating. Okay, such that the square of the smaller integer, so the smaller integer is x. That should be red. The smaller integer is x. I'm going to square it. And it says it is, so that's equals, is 10 more than the larger integer. So 10 more than the larger. The larger integer is x plus 2, and then 10 more than that. And that is how I set up my equation. Now to put all of this together, okay, this is going to give me 12. And I'm actually going to subtract that 12 from both sides. And I'm going to subtract that x from both sides. Because in order to solve my quadratic, I want to put everything on the same side. So I'm going to have x squared minus x minus 12 equals 0. And I'm almost finished. Now I'm going to do my x puzzle. My a value in front is a 1, so I don't need to do anything else. I just jump straight to the x puzzle. And I want to come up with two numbers that will multiply to give me 12. So I think 3 and 4. But they do have to add to give me -1. So let's do 3 minus 4. X plus 3, x minus 4. Okay, and then in class, here was our shortcut. We were just jumping right to the answer instead of solving it every time. So x here, if you subtract 3 from both sides, x is -3. Here, if you add 4 to both sides, x will be +4. Okay? Now, we did want to keep the positive solution only. That's what the word problem said. So we're going to ditch that -3. And now we're going to find what are our two integers. So I take this and I plug it in up here. Well, x equals 4. Okay, and then what is 4 plus 2? That is 6. So those are my two numbers, 4 and 6. And that's it. Let's look at our third type of problem. This was the last type of problem that we looked at, but we did explore how to solve these using our formulas and our algebraic methods. And then we went to desmos.com and we learned what to look for on that graphing calculator. So I'm going to do two examples of projectile motion. One by hand, like we did on examples 1, 2, and 3 in our notes. And then the other example will be on the Desmos calculator. Okay, so I've already gotten us started. A toy rocket is launched from a platform that is 48 feet high. Okay, so I've got a rocket and it's being launched off of a platform here that is already 48 feet in the air, which means that the ground is down here somewhere. Okay. The rocket's height above the ground is modeled by this function that they give us. All right, we're going to find the maximum height of that rocket, which the maximum height will be right around here somewhere. Okay. To find the x value of that vertex, the first thing that we need to do is identify what is our a value and our b value from the equation. My a value is -16, so where I see this a in the formula, I'm going to put -16 there. The b is a +32, so where I see the b in the equation, I will put 32. And then I'm going to reduce this. -32 divided by -32 will give me a +1. Next step, what I'm going to do to get the y value, and actually they're not using x and y in this equation, they are using h and t. So what we just found was the t value. Now we're going to go find the height. We're going to do this by plugging that x or t value into the function. So h equals negative 16 plus 32 plus 48. Okay, so I'm going to take that one right there, and I'm going to plug it in down here. And then I'm going to simplify. And you can use your calculator for this, that's fine. Negative 16 times 1 squared is negative 16. 32 times 1, and then bring down the 48. Let's see. 48 and 32 is going to give me a 0 and then an 8. And then what is 80 minus 16? I think that's going to give me 62. Okay? And that is the second part of my vertex. So let's see. My vertex is 1, 62. And what that means, since 1 is the t, it's going to take 1 second for my rocket to reach a height of 62 feet. Okay, not so bad. Part B, what time will it take for the rocket to reach the ground? Well, when the rocket hits the ground, it's going to be down here. Okay, you have to think about what is the height when you're on the ground. The height when you're on the ground will be 0. Whoops, I want that to be smaller. So h equals 0. So what I'm going to do for part B is I am going to put a 0 into the original equation where the h is. Okay, so I'm going to draw a line. Instead of h equals, I will put 0 equals negative 16 t squared plus 32t plus 48. Okay, now I need to start to factor this. Let's see, 16, 32, and 48. I think they all have an 8 in them, but let's see if they also can go bigger. Let's see. Yeah, they all have a 16 that they're divisible by. So let's take out this negative 16 times 1, negative 16 times 2, and actually negative 16 times negative 2 gives you a positive 32. And then negative 16 times negative 3 will give me 48. So I'm going to take out that GCF of negative 16. And then write that out to the front. So I've got left over 1t squared minus 2t minus 3. And I'm going to do my x puzzle. Minus 3 in the top, minus 2 in the bottom. There's only one way I can think of here. That would be a negative 3 plus 1. Okay. And then again, I'm going to want the answer that when I solve it, it gives me a positive result, because my answer here is talking about time. So that one will require me to add 3 to both sides to solve it. So x equals 3 here. And what that means is it will take 3 seconds for that rocket to hit the ground. All right, so my answers here, my final answer for part A was 1, 62. My final answer for part B is 3 seconds. And so by hand, that is a lot of algebra. You do have to memorize the one formula. And I like to draw the picture because it helps us understand and see what's happening. Let's go see what that would look like in Desmos, where I don't necessarily have to draw a picture. So projectile motion using Desmos. I've already kind of written out the steps here for us. So when Joey dives off a diving board, here's the diving board. He is going to jump up, and then he's going to go down, and he's going to land in some water. Okay, that's kind of what's happening here. They give me the equation, and that's what I'm going to need to type into Desmos. When I get to Desmos, if you look at part 2, we're going to find the maximum. This point right here is the maximum. By moving our graph, by zooming in or out to see the vertex, and then we're going to click on that point. The maximum is going to be an ordered pair, x and y. The x value represents the time. The y value represents Joey's height. And then part 3, we're going to find how much time it is going to take for Joey to come down here and land in the water. When he lands in the water, okay, that's going to be an x-intercept, or a 0 of our function. We want to find the one that's the furthest to the right, okay, because that will give me a positive value, and time must be positive. So let's go take a look at Desmos. So my equation is, now remember in Desmos you are allowed to use any letters that you want, so we don't have to convert back to using x and y. We can use h equals I forgot what my function was. Let's go back. Negative 16t squared. So negative 16 t, and then the square button is that a squared, plus 15 t plus 12. Okay, so I've typed in my function. What I'm going to do is you can move this around like this, or you can just zoom in and out with this plus and minus sign on the side. Now right now there's no points to highlight on my graph. So if I click on my function, the h equals, and I highlight it, and now you see there's a blue box around it. You see that there's these points right here. And if you click on that high point, that's the vertex. That gives you the time, which is 0.469 seconds, and the height, 15.516. Okay, so 0.469 comma 15.516, and that's what I would write for my answer. Then the next thing that they wanted to know is, when does he hit the water? Well, if I click on this one on the right, on the left, I can see that my x value is negative, so that would be negative 0.516 seconds. Time can't be negative, so we want to do the one on the right, which is going to give me a positive result, and that is 1.453 seconds. Okay, wait for the bell. And then I do just want to show you that if you clicked on the y-intercept up here, that says 0,12. That is the height of the diving board that Joey is standing on before he jumps. So you notice he doesn't actually jump up very high, but he does go up a little higher before he falls back down to where the pool is. And so that kind of gives me my picture to look at. Okay, so I did write my answers down, but let's bring them over. So the vertex to part A was 0.47. I'm just going to simplify that a little bit. And then the height was 15.52 feet. So that's feet, that's seconds. And then when did he land in the water? He hit the water at, right there, at 1.45 seconds. So I've answered parts A and B. I hope this helps. Good luck reviewing. We've got a review day in class tomorrow, and then we've got our test on Thursday.